Okay, Algebra 1 students, in this video today we will continue to solve linear equations. Alright, now, as I mentioned in your last video, we will continue to do this, and the equations will slowly become more and more difficult. Okay? So we're going to be looking at linear equations for quite a few videos. I would like you to copy down your heading for today. Please copy that down. Solving linear equations, lesson 3.2, and be sure and include today's date. Alright? Solving linear equations, please copy that in your notes. Lesson 3.2, please copy that in your notes, and be sure and include today's date. Now, let me start off today by showing you a very common mistake that students make as the equations become more difficult. Alright? Now please write down these. There's three. Please write down these three examples, okay? And we're going to compare them and talk about them. And I'm going to show you the difference between these three equations, alright? So take a second, and I'm not sure where the third one is. There it is, okay? Now take a second and copy down these three equations, if you would, please, okay? Copy these down. I will give you just a second to do that. Please copy these down. Okay, now listen carefully. Anytime I go too fast, just pause the video. Now, we have learned that when you're solving equations, you simplify both sides. We talked about that, okay? And then we talked about getting the variable by itself, or in other words, we call that isolating the variable, okay? A-B-L-E variable, alright? So we've talked about doing that in our last video, and you guys learned yesterday to take this 3, bring it over and make it a -3, and your answer would be 18, okay? Don't take notes on this, just watch, okay? Do not take notes, just watch. Now, when I look at this problem here, I hope everyone's listening. Listen carefully when I look at this problem here. A lot of students see the x, and they want to get x by itself, so they cross off the 3 and bring it over and make it a -3. And that's wrong. I'm going to show you why in a second. They see this +3 here. They bring it over and make it a -3. And that's wrong. And here's why. Please listen carefully. When you move something in an equation, you must move whole terms. You probably ought to write that down. When you move something in an equation, you must move whole terms. You cannot move part of a term, okay? You cannot move part of a term. Now you're seeing how math builds, because back in chapter 2 we talked about terms, and we talked about positives and negatives make a term. Okay, we talked about that in the last chapter. Okay, and now you're seeing why it's so important you understand that. You see, look at this. Right here, I have two terms. I have two terms because of this positive sign here. If it would have said 3 minus x, I would have two terms because of this negative sign right here, or minus sign. Okay? Positives and negatives, or pluses and minuses, however you want to say it. Positives and negatives, or pluses and minuses, make terms. Okay? Well, look, there's no plus sign here or a minus sign here. They're side by side, they're multiplying. That's one term. Do you see the difference between this and this? Two terms, one term. Now, why is that important? Because you cannot split up a term by moving it. You can't take part of this 3 and move it over. That's part of the term. If you want to bring the 3, you got to bring the x with it. You got to bring the whole positive term, bring it over and make it a -3x. Now that's legal there. You can do that. But you cannot move part of a term. Look at this. You cannot move the 3 and bring it over. You cannot do that. You have to move the whole term. You have to bring this entire positive fraction over and make it a negative fraction. Okay? which is not going to help you, so we're not going to do that. But my point is this. When you move things in an equation, you must move terms. You cannot move part of terms. Okay, now hopefully you see the difference between these three equations, okay? Hopefully you see the difference. Because if you don't, you're going to be moving things when you shouldn't be moving things. You must move complete terms, okay? Now, having gone over that, let's look at our steps for solving linear equations, and then look at some examples that we can practice. By the way, I told you the other day that as we do more and more difficult equations, I will add to your steps, okay? However, I will not always do that. So today I am not going to add to your steps. They stay the same, okay? They stay the same. So you don't have to copy these down if you don't want to. They're the exact same steps as yesterday, alright? Simplify both sides of the equation. Isolate the variable. Got it? So here we go. Let me get a drink here real quick. Here are some examples that we are going to solve. Are you listening? Listen carefully. Just like I told you in the previous video, I am well aware that you can solve most of these, if not all of these, in your head. I get that. That's great. However, the day will come when the equations will be too difficult for you to do in your head. You then must be able to solve those equations by using the techniques and steps that I have taught you. So you must show all of your work on these equations in your notes and in your homework and tests and quizzes. You must. If you don't show work, you will get 0 credit. Okay, I'm a stickler on this, so I've made myself clear. Alright, here we go. Let's start with this first problem here. Now, 6x equals 18. Please follow along. Watch carefully, please. First of all, simplify both sides. Well, there's obviously nothing I can do to an 18. I can't simplify the number 18. I also cannot simplify 6x. I mean, if you think I can, then tell me what you would do. There's nothing you can do. 6x means 6 times x. Now, I'm well aware of the fact that you know the answer is 3. I know that. You know that 6 times 3 is 18, but I want you to show your work. Now, step 1 is simplify both sides. We just talked about that. You cannot simplify this side. You cannot simplify this side. So, we have to do something else. On to step 2. Isolate the variable, or in other words, get the variable. In this case, it's x. Over here, your variable's y. Here it's b. Here it's r. Isolate the x, or get x all by itself. So here's what you do. You can't just bring the 6 over, because that's part of a term. You can't just split a term up, okay? So we use something called opposite operation. If you want to write that down. Opposite operation, okay? And here's what I mean. What is the 6 doing to the x? It's multiplying. What's the opposite of multiply? Divide. So we're going to do the opposite of both sides. Excuse me. We're going to do the opposite of this function right here to get rid of the 6. So the 6 is a multiplying 6, so we're going to divide by 6. However, to keep the equation equal, what we do to one side, we must do to the other side. So if we divide this side by 6, then we also must divide this side by 6. Now, why did we divide by 6? Why didn't we divide by 5 or 18 or 2 or 10 or 3? Here's why. What number are you trying to get rid of so the x is all by itself? You're trying to get rid of the 6, correct? So whatever number you're trying to get rid of, that's what you divide by. So here, your 6's cancel, and look at that, x is all by itself. Is that legal to do? Sure it is. You did not move anything from side to side. That's totally fine. 18 divided by 6 is 3. And there's your answer, just like that. That's pretty simple, guys. It really is. Okay? Alright, let's take a look at the next example. Number number 2 here. Okay, now use your steps. Don't think you're getting too big for your steps. Step 1, simplify both sides. You cannot simplify this side, it's just an 8. You cannot simplify this, there's nothing you can do with y divided by 4. So on to step 2. Step 2 is get y by itself. If I want to get y by itself, or isolate the y, what do I have to get rid of? What is with the y that I want to get rid of? A 4. So why not just bring the 4 over and change the sign like I've taught you to do? Because if you do that, you're moving part of a term. This is one whole term right here. And you cannot split up a term when you're moving things. So we're going to have to do something else besides move. Okay? We're going to use opposite operations. What is the 4 doing to the y? It's dividing. What's the opposite of 4? Excuse me, what's the opposite of divide? Multiply. So I'm going to multiply this side by what? 4. And I'm going to multiply this side by what? 4. There we go. When you multiply y over 4 times 4, the 4's cancel, leaving you with y. And over here, 8 times 4 is 32. And there's your answer. We're finished. Now let's check our answer, see if we got it right, okay? Where the y is, I'm going to substitute 32. Cross off the y and put 32. What's 32 divided by 4? 8. 8 equals 8. It checks. Okay, let's try another one. 2 more and we'll be finished. Okay, you can work it if you want to. Make sure you keep one eye up here. Make sure you're doing it correctly. Okay, step 1, simplify both sides. I cannot simplify a negative 4 and I cannot simplify a negative 7b. There's just nothing I can do, okay? Step 2, isolate the variable. In other words, get b by itself. What is with the b that I want to get rid of? A negative 7. Now, in the past, you might think we'll take that negative 7 and move it over to the other side and make it a positive 7. Okay? That's a really good thing to do if the problem looked like this. Negative 7, positive b. If it looked like that, then I have 2 terms. This is a term all by itself, and this is a term all by itself. So you can bring the negative 7 over and make it a positive 7. Do you see the difference? Do you see the difference, guys? Okay? This is not 2 terms right here. This is 1 term. So you cannot just split up the term by moving the 7 over. You have to use opposite operations. So what is the negative 7 doing to the b? It's multiplying. What's the opposite of multiply? Divide. What number are you trying to get rid of? Negative 7. So we divide both sides by a negative 7. These cancel, leaving you with b equals. Now look, a negative over a negative, or in other words, you have a negative divided by a negative. Remember, a negative divided by a negative is positive, so negative divided by a negative is positive. And I would like you to leave your answer as a fraction. Just leave it 4 sevenths. I don't want a decimal. Just leave it 4 sevenths. Now, if this would have been 4 eighths, then I would expect you to reduce it down to 1/2. Always reduce your answers, always, okay? But in this case, we have 4 sevenths, and there's really nothing we can do with that reducing wise, so that's your answer, okay? Now let's see if we got the right answer, shall we? Here we go. I have a b right here, so I have negative 7 times 4 sevenths equals negative 4. Let's see if that's right, shall we? Let's work this out and see what we get. First of all, put your 7 over 1 times 4 over 7. Alright. You have a negative times a positive, a negative fraction times a positive fraction. That's negative. Your 7s would cancel. 1 times 4 is 4. 1 times 1 is 1. 4 over 1, of course, 4 over 1 is just 4. And look at that. Negative 4 equals negative 4. It works. Okay? So, always check your answers, guys, to make sure you're doing them correctly. And then last but not least, this equation here. Now let's take our time here, okay? Use your steps. Step 1, simplify both sides. Well, I can't simplify simplify this side, and I cannot simplify this side. There's nothing I can do. On to step 2. Isolate the variable. In this case, the variable is an r. Isolate the r. Got it? I want to get r all by itself. So if I want to get r by itself, what number do I want to get rid of? -5. Okay? So you do not want to take the -5 and bring it over and make it a +5. Please do not do that. Why? Because this is one term right here. Got it? That's one term. And if you move the -5 up, you're splitting up a term. You cannot split up a term by moving it from side to side. You cannot do that. So I'm going to use opposite operations. What number do I want to get rid of? -5. What is a -5 doing to the r? Dividing. What is the opposite of divide? Multiply. So I'm going to multiply both sides by a -5. Okay? Now here, your -5's cancel, leaving you with r. Over here I have a positive times a negative. Positive times a negative is negative. 20 times 5 is 100. So there's your answer, -100. Okay? Now let's see if that's right. Here's an r right here. I'm going to cross that off and put a -100. Okay? What's a negative divided by a negative? Positive. What's 100 divided by 5? 20. 20 equals 20. It checks. There's your answer. Guys, it's amazingly important you understand the difference between equations that look like this, this, and this, okay? When you have different terms, you can move those terms around, that's fine. But never move just part of a term. If you're going to move something from side to side on an equation, you must move whole terms. You cannot move partial terms, okay? Guys, I really hope this video has been a help to you. If you have any questions, don't hesitate to call or email.